In this video, we'll examine the binomial probability distribution. We'll use the in-chapter example of the Nasky clothing store to illustrate the various calculations in the binomial distribution. These include the expected value or mean, the variance, and the standard deviation. In the text, we're provided with some information to construct a small problem. For the experiment, the store manager estimates that the probability of a customer making a purchase is 30% and asks what is the probability that exactly 2 of the next 3 customers make a purchase. Of course, we have some characteristics of the problem that have to exist in order for the binomial distribution to apply. The experiment is described in a sequence of 3 identical trials, so there are identical trials. There are 2 outcomes possible for each trial. The customer either makes a purchase or they don't make a purchase. The probability of a purchase is 30%, therefore the probability of no purchase is 70%. These trials are mutually exclusive. The purchase decision of each customer is independent of the purchase decision of the other customers. So each trial is independent of the previous trials. So we're going to do 3 trials. If you don't have your worksheet set up like this, go ahead and set it up. You can leave this equation out if you'd like. I put it in here just for our reference. It's the equation that's in the text to calculate the probabilities in a binomial distribution. We have the number of identical trials, or n, which in this case are 3. And we have the probability of a purchase, which in this case is 30%. Center those so you can read them a little bit easier. We'll go ahead and calculate the probabilities based on the number of customers. We have no customers, 1, 2, and a maximum of 3 customers that could come in. Now we'll use this function. Let's break down this equation. We have a numerator here. I'm going to calculate that first. Then we have a denominator. I'll calculate that second. Then I'll put these 2 together and solve this fraction as a unit. Then I'll multiply this times, I'll go ahead and solve for this, multiply these 2 together as I construct the equation in Excel. So I'll begin by solving for the fraction portion. Here's the numerator, n factorial. The Excel function for factorial is fact. I want n. I'll make that absolute because I do intend to copy this down. So there's the numerator. So I'll put that over, and then x factorial. So I want fact of the x value, which is here. I'll leave that relative because as I copy it down, I want it to change. Then I want to multiply that times the factorial of n, which I will make absolute, minus x, which I will leave relative, so it changes as I copy it down. Now we've solved for our fraction, and we'll multiply that times the quantity p, the probability, and I'm going to make that absolute and raise that to the x power. I'll leave that relative, so as I copy it down, I get it. And I'll multiply that times quantity 1 minus, again, back to p, make that absolute, raised to the n, make that absolute, minus x. Leave that relative, so when I copy it down, it works. There's my denominator. I press enter. I get 0.343. I'll center that and then copy that down, and there are my probabilities of each level, number of customers making a purchase. I'll go ahead now and use the traditional method to solve for the expected value or the mean, and then the variance and the standard deviation. We solve for the expected value by taking x and multiplying it times f of x, probability of x. I'll copy that down, make these the same size just for ease. And that gives us our expected value, which we'll go ahead and place here. I'll place a line, sum these up to get the expected value, equals sum. So our average outcome, or our expected outcome, is 0.9. I'll center that. Let's label that. Now we'll do the following steps to calculate the variance and the standard deviation. We need to take x and subtract that from the expected value. And we'll make that absolute, so we can just copy it down. Then we need to square each of these, raise that to the second power. Copy that. Then we need to multiply each of these times the probability of their occurrence. So we'll take this squared value and multiply it times f of x, and then copy that down. That gives us the variance for each occurrence. Draw a line there. Go ahead and sum these. Sum of the variances gives us our variance for this problem, 0.63. And of course, the standard deviation is simply the square root of the variance. And that gives us a standard deviation of 793.793. Let's go ahead and label those just very quickly here so you can see them. All right, that's the long way to do it. The traditional way, Excel provides us with a much simpler method to do this. So let's go ahead and solve this using the preferred method. Call this the preferred method. This is the method I recommend you use in class. You can use the one above. It's no problem. You'll get the correct answer. The preferred method will just get you there faster. So we're going to have x and f of x, these two columns. Center those. Zero, 1, 2, 3. Come up just a little bit. All right. Now, instead of entering the complex formula above and running the risk of making a mistake, we're going to use the Excel function called the binom.dist. And it wants a number which is in fact x. So we'll give it x. We'll leave that relative. So when we copy it, then it wants to know the number of trials. That is 3 in our problem. Make that absolute so we can copy it. Then it wants to know the probability of success. So we'll make that absolute so we can copy it. That's P. And we're going to answer false to the cumulative question. We want the probability of 0 in this case, or of x, not the cumulative 0, 2, 0, 0 to 1, 0 to 2. That's the cumulative. So we'll press enter. That gives us, as you can see, the same answer as above. I'll double click. That brings it down. All the same as here. Just a lot quicker and easier, more accurate. Now let's solve for the expected value the variance and the standard deviation. We're given some equations in the text. Let's put those here for calculating these. The text tells us that the mean is equal to n, number of trials, times 0.3. Another way of calculating that, you can just do that little bit of multiplication, or you can do this calculation and add them up and reach that. It's your choice. The variance is defined in the text then as n times p, or the mean, times 1 minus the probability. That gives us the variance. You can see again, that's the same answer as we got over here going through all of these steps. And the standard deviation is always the square root of the variance. And that gives us our standard deviation. There are a couple of ways to go about this. This one, many more steps, many more opportunities to make a mistake. Takes you longer to do it. Or using the Excel formula for the binomial distribution, entering those values and just letting Excel return the value. The binomial distribution is a discrete distribution, therefore the equal sign has meaning. You can find a specific value, the probability of a specific value, so false is appropriate, whereas in other distributions we'll see that false is not appropriate. But for the binomial, we can find the probability of a specific occurrence, so false is usable. That's how you use the binomial distribution to find the expected value, variance, and standard deviation.